Recorded's rolling. It's Tuesday, May 20th. Yesterday I was going over the solutions to the FRQs with the guys. We got through the first three. We started looking at number four. So I've got to finish that right here. Okay, and then going back to about late January, my classes all split off. And my other classes, like my honors classes, have been learning a lot of topics that you guys haven't gotten just because they don't show up on the AP exam. Right, like here's a list right here. I know I did about 3 days of electricity circuits with the guys, which isn't enough, but it's maybe better than nothing. Right? And my plan today, after I finish the solution, is to I'm going to pull up a PowerPoint and try to tell you guys much about theory of relativity, quantum mechanics if I can. So we'll see how that paces out. All right, so we're looking at number four right here. We got see swimmer with a block. Right, now it starts in a freshwater tank with the density of the water is ρ1. The block is released from rest and it accelerates upward. Hey guys, the fact that it accelerates upward, which direction is the net force? Upward, right? And if you made a free body diagram, well, okay, you probably would come up with this, right? So there's a weight down, there's a buoyant force up, and the buoyant force up is more than the weight down. Okay? So that if you took the difference between those two, that would be the net force divided by the mass of the block to get the acceleration. Okay? Also, it says frictional forces are negligible. They're talking about the drag force from the water, which in real life that would definitely be a significant force, right? Or you could say this is true, like right at the moment that it releases the block, right? Because once it goes in motion, realistically, there's a drag force. Don't worry about that because that gets complicated. Okay. And scenario two, I was going to go into a saltwater tank, and saltwater, guys, is saltwater denser than freshwater? Yeah, it is. Now, freshwater is almost exactly 1,000 kilogram per cubic meter. That's what the metric system was designed around. Okay. But saltwater is, I think it's something like 2, 3, 4%. Or I mean, it depends how salty we're talking about, right? Talking about ocean water. Okay. Again, release from rest, block accelerates up, drag force is negligible. Right, so indicate, okay, guys, now that he's in the salt water, so it's the second scenario. Which box did you guys check? Let's see, show of hands. Let's get that not blurry first. All right. All right, so you guys see those options? You guys know scenario one is freshwater, scenario two is saltwater. Right. How many guys checked the first option? Who checked the second option? Yeah, there you go. I see. So lots of hands on that one. Right? Because what you could say then is that if the difference is this rho, if this rho increases, then this whole buoyant force increases. So the net force upward would increase. I think they want you to spell that out. Right, so justify your answer in terms of all forces exerted on the block. Well, really, there's only two that matter because we're going to ignore drag force. Right? So the buoyant force and the weight. Use qualitative reasoning beyond referencing equations. Okay, so they're looking for maybe like a couple of sentences. Right. Okay, and then there's a part B and part C. So here's what I wrote for part A. Hopefully your answer looks somewhat like this. I think this is pretty good. Density 2 is greater than density 1. The buoyant force 2 is greater than buoyant force 1. The weight of the block is the same in both scenarios. Imagine that Navin point, who knows, I don't actually have a scoring rubric. Okay. Therefore, the net force is greater in scenario 2. I mean, having seen so many of these scoring rubrics in the past, their logic would probably go like this. Right? Okay. Buoyant force is different, weight's the same, the net force is greater than scenario 2. Then we'll kick over to Newton's second law of motion because the question was something about acceleration. So acceleration is net force on mass, therefore the acceleration is greater than scenario 2. Right? So hopefully you mentioned Newton's second law somewhere in there. Right? Newton's second law was almost certainly a point. Consider a case block mass M, volume V is completely submerged in fluid density rho, which means that the volume of the block would be the displaced volume. Right? That's why it's completely submerged. Starting with Newton's second law, ooh, they're really helping you guys out there. Derive an expression for the initial upward acceleration of the block, release from rest. Now, really, if there was no drag force or you always ignore drag force, they could throw out the word initial. But realistically, right, you could really just solve for that from this class, initial. Right, express your answer in terms of the mass of the block, the volume, the density. Guys, in this row, remember, this is the density of what? The block or the water? The water, right? Surrounding fluid, right? And physical constants, maybe gravity field matters, right? Although I wonder if that's going to cancel out. Oh, well, we're going to see. Right? Begin your derivation by writing fundamental physics principle, blah, 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 right? Which is probably Newton's second law. So see what I came up with here. Right? Yeah, I start with Newton's second law of motion. That's the first thing I would write. Acceleration is net force on mass. Now the net force would be the buoyant force minus the weight. Okay? And then remember, you want your final answer to be in terms of all those variables that they mentioned. So in place of buoyant force, I'm going to go rho GV, right, straight from the equation bank. Right, but you guys know that anyway. Right, minus mg, and then all divided by mass of the block. Okay. And here, you could break this into two separate fractions. You don't have to. I think either of these should be an acceptable answer. Okay. By the way, it looks like gravity field did not cancel out. I was wondering for a minute, would it? But no, gravity field ends up staying. So if you have either one of those, here, guys, show of hands. How many guys think you probably got that? Who thinks they got that? Oh, that's almost everybody. Awesome, awesome. Yeah, great. Okay. All right. Oh, okay. So that should be part B. However they support that, and then part C indicate whether the expression for acceleration you derived in part B is consistent with the claim you made in part A. Again, you guys have seen lots of these. Ideally, the answer is yes, and that would be the case here too. Right. And then how could you point to this equation to back that up? So, do you guys see? Here, maybe here's one way to say it. If you increase this row, like if you keep this full fraction form, then wouldn't the numerator of the fraction be increased, and therefore the acceleration would be greater? Right? But what I write here? I write the expression for acceleration is consistent with the claim made in part A. Gravity field, volume, and mass are all the same for both scenarios. The expression indicates that a greater fluid density rho results in a greater acceleration A. Yeah, maybe I should have written the word numerator in there somewhere. That maybe it's something they were looking for. No, talking about functional dependence is what they're getting. All right, so that's it. That's all the FRTs. All right, so you know what else? Here did well here. All right, that's enough. All right, so you guys got on that? All right, so let's switch over to PowerPoint here.